In this video, we are going to see what is the Pythagorean theorem or Pythagoras theorem. They call it with both names. So based on the Pythagorean theorem, for a right triangle, the square of the longest side is equal to the sum of squares of the other two sides. So based on Pythagorean theorem, I can write c square is equal to a square plus b square. It is very important to know that this theorem is only and only correct for the right triangle. So you might ask, what is the right triangle? Let's take a look here. The right triangle is a triangle in which one of the angles is 90 degrees. So in this triangle, if we agree that this angle is 90 degrees, I can call this triangle a right triangle. And I can call this angle the right angle. And also the name of this longest side here is hypotenuse. So in this triangle, let's say this angle is 90. So I can say that this is a right triangle and this is the right angle. And this is the longest side that I can call it hypotenuse. Again, here, this is 90 degrees, so this is a right triangle. This is the longest side, and again, I can call it hypotenuse. So now that we know what is the Pythagorean theorem for the right triangle, let's take a look at some examples. So in this problem, we have the triangle ACB. We have these sides 9, the length of these sides 12, and we want to find the length of the longest side here, which is the length of the hypotenuse, based on the Pythagorean theorem. So based on the Pythagorean theorem, I can write, let me name these sides. I'm going to name this A, B, and let's say side C. Now I can write c square is equal to a square plus b square. So c square is equal to 12 square plus 9 square, which means c square is equal to 144 plus 81. C square is equal to 225, and therefore c is equal to square root of 225, which will be 50. So now let's take a look at another problem here. We have this triangle. This side is 7, this side is 10, and we are going to find the value of the length of this side. First of all, I know that this angle is 90 degrees. Therefore, this is a right triangle, which means now I can use the Pythagorean theorem. So if I name this triangle as A, C, B, which means this is C, this is B, and we are going to find the value of A. So based on the Pythagorean theorem, I can write, this is the longest side. I can write c square is equal to a square plus b square. 10 square is equal to a square plus 7 square. 100 is equal to a square plus 49, which means a square is equal to 51, and a is equal to square root of 51. You can leave it like this, or you can calculate this with your calculator, which will be approximately 7.40. So now take a look at one more problem, which is the last one. So in this problem, we have this triangle here. We have the value of BD as 3, AD as 7, and the length of BC as 5. And the goal here is to find the area of the triangle ACB. So let's see how we can use the Pythagorean theorem to calculate the area of this triangle. First of all, we know that the area of this triangle, I can write it like this. So if I call it S, the area of triangle ACB will be 1/2 times the base, which I have it, is 7 plus 3. So I write it as AB, the length of AB, times the height, which is the CD. I have the AB, as I said, 7 plus 3, but I don't have the length of CD here. So first, I should find that. How can I find that? If you look here, the triangle BDC is a right triangle. Why? Because this angle here is 90 degrees. Because the line CD is perpendicular onto BD. So this is 90 degrees, and therefore this triangle is a right triangle, which means I can use the Pythagorean theorem here. So let's start with that. I can write the square of the longest side here, 5, and I'm going to call this line, let's say, A. So I can write 5 square is equal to 3 square plus A square. So I'm talking about the triangle BDC. Triangle BDC. So 25 is equal to 9 plus A square. A square will be 16, which means A is equal to 4. So now I have the A, which is the length of line CD, which was this length that I needed to calculate the area of triangle ACB. So now I can, based on equation, let's say 1 and equation 2, I can write the area S of triangle ACB as 1/2 times base, which was 7 plus 3, 10, times the length of CD, which was A, which we found it here as 4. So the area of triangle ACB is equal to which the answer will be 20. That's it. It would be great if you liked the video. See you all soon, and peace.